Hello again, this is PreCal Lesson 4.3, Right Triangle Trig. We're going to see how the right triangle trig correlates to the circle trig today. So we're still talking about sine, cosine, and tangent, and their inverses, cosecant, secant, and cotangent. And then here's our right triangle. Make sure you're familiar with the parts of a right triangle. It does have to have a right angle, and across from the right angle will be the hypotenuse. We're going to look at this acute angle theta right here. Across from theta will be what we refer to as the opposite leg, and then next to it will be the adjacent leg. And I refer to the hypotenuse, the opposite leg, and the adjacent leg as R, Y, and X respectively. So you've learned this a long time ago back in Math 3. It's called Sakatoa. You know, the trig Indian princess. Which means that sine is equivalent to the opposite leg divided by the hypotenuse, so opposite over hypotenuse here, and that cosine is equivalent to the adjacent leg divided by the hypotenuse, and that tangent is equivalent to the opposite leg divided by the adjacent leg, and then of course cosecant, secant, and cotangent are the inverses or the reciprocals. But we can also identify these parts as again, x, y, and r. So sine would be y divided by r, cosine x divided by r, and tangent y divided by x. And then, of course, your inverse is over here. We also use Pythagorean theorem with our right triangle trig, which you learned as c squared equals a squared plus b squared. But for our purposes in trig, we're going to use r squared is equal to x squared plus y squared. So, why do I call this r? I am so glad you asked. If you look at your unit, that is not a circle, Miss Letchworth. Let's pick up a circle here. There we go. Whoa! That was too big. Okay, there we go. All right, so if you look at your unit circle, of course, is divided into 4 quadrants. And if you were to draw a radius on your unit circle and then choose the point that radius intercepts, and you drop down a perpendicular segment to the x-axis, then you get a right triangle. In this right triangle right here, the hypotenuse of that right triangle is the same as the radius of that circle, so that's why I call it R. And then I call this side X and this side Y because, so this is called X and this is called Y because of this ordered pair right here is in the form of XY, where from the origin to that point you would have to move X units to the right and then Y units above or up to get to that ordered pair right there. So that's why I refer to the sides of the right triangle as X, Y, and R. Alright, so we're going to use all this information to work some problems, and our first one is to find the 6 trig functions of theta. Well, if you look at what you're given here, and this is a right triangle, I forgot to put my right angle in there. We need to figure out what x is. So when you know the 2 sides of a right triangle and you want to know the third one, then you can use Pythagorean theorem. Identify your parts. Across from the right angle is your hypotenuse, which is r. This is x, so this must be y. So we're going to use r squared is equal to x squared plus y squared. And we're going to figure out what this is. Okay, now you shouldn't have to do this every time because there is a such thing as a Pythagorean triple, and I'm going to have you to become familiar with those so that you don't have to do this math every single time. Let's come up here. If I subtract 25, I'm going to get 144. And x is technically plus or minus 12, but we're just going to say 12 because it's a segment and segments are not negative. So x is 12. You need to memorize this one. This is one of them. If you have a right triangle whose segments are 5, 12, and 13, then that is referred to as a Pythagorean triple because everything is an integer. And then, of course, any multiple of that would be a Pythagorean triple as well. So that'll be one that you'll become very familiar with, and you can just memorize it. But you always have to make sure that 13 is that hypotenuse and that it's not one of the legs. Don't let them sneak that one in on you. So you're just going to follow your formulas that I gave you at the very beginning, that sine is equivalent to y divided by r, or opposite divided by the hypotenuse. And cosine is x divided by r, and we just found x to be 12. So we're going to say that that is 12 divided by 13. And tangent is y divided by x. So that will be 5 over 12. And then so now you're just going to flip these to get the inverses. Okay, for problem 2, this one is given to us a little bit differently. We don't have a triangle. This time it gives us one trig function and it asks us to find the other 5. So you can draw your own triangle given this information. Okay. So let's put our information up there. This is my right triangle. I'm going to call this theta. And I am given that cosine theta is 5 over 7. So I'm going to, of course, call this r. And you can call these two sides x and y. I like for my vertical segment to be y because that's like my vertical axis. And for this, my horizontal segment to be x because that is my horizontal axis. And according to this, cosine theta is 5 over 7. Well, I know my formula for cosine theta is x over r. So what that tells me is that this side must be 5 and that this side must be 7. Again, I'm going to have to use Pythagorean theorem to figure out what y is. So I'm going to use r squared is equal to x squared plus y squared. And that's going to be 7 squared is equal to 5 squared plus y squared. So 49 is equal to 25. Plus y squared. And then if I subtract 49 minus 25, I get 24. So y is the square root of 24, and when I simplify the square root of 24, I get 2 times the square root of 6. So then I am going to figure out what sine, cosine, tangent, cosecant, secant, and cotangent are. So again, sine is y divided by r. Cosine was given to me, but I always list the ones that are given to me. I just like to list all 6 of them together. Tangent is y divided by x. Cosecant, I'm going to flip sine. Secant, I'm going to flip cosine. Cotangent, I'm going to flip tangent. And then I'm going to come back and I am going to rationalize these denominators. So that's 7 times the square root of 6 over, that is 6 times 2 is 12. Something doesn't look right, does it, Miss Letchworth? What did you do? Sine is y divided by r. That's right. Tangent is y divided by x. That should be a 5 right there. There we go. I knew something wasn't right. And then right here, I need to make that a 5. There we go. Now that's all better. So this is 5 squared root of 6 all over, that is 6 times 2 again, which is 12. Okay? All right. Here we have that if cotangent of theta is 5, find cosecant. So this is just asking for one trig function, but we're going to do it the same way we did a while ago. We're going to sketch ourselves some kind of right triangle. And this is my right angle here. This is theta. Cotangent, I know, is y divided by, that didn't turn out pretty, did it? Let me try again. Is y divided by x. Here, that is, cotangent is 5. But I can write that as 5 over 1. So what I know is that my x is 1. My y is 5, and I need to figure out what r is. So again, r squared is equal to x squared plus y squared. So r squared is equal to 1 squared plus 5 squared. So r squared is equal to 26. So r is the square root of 26. So if I want to find cosecant of theta, then I know that cosecant theta is given to me as r over y, because that's the reciprocal of sine. So cosecant theta will simply be square root of 26 divided by 5. Okay? All right? Okay, so here, this one says to solve for x, and x is a side. Notice that this time, we're not going to be able to use Pythagorean theorem, because with Pythagorean theorem, you've got to know 2 out of the 3 sides. And here, I just know one side. I don't know this side. But I've got to find x. But what I do know is an angle. This is when SOHCAHTOA comes in handy. Okay? In reference to this angle, I can identify the sides as opposite, because this is the side that's across from that angle. Adjacent, because this is the side that is right next to this angle. And then this is my hypotenuse. Okay? So if I want to figure out this side, then what I want to do is use either sine, cosine, or tangent, not all 3 of them. You got to choose one. But choose which one that will help you to find x. Well, x is the adjacent side, and we know the hypotenuse. Well, which trig function uses those 2 sides? Cosine. So I'm going to use cosine theta is equal to adjacent over hypotenuse so that I can figure out what x is. And I'm just going to plug in the stuff that I know. I know my angle, theta, that's 60 degrees. My adjacent side is x, and my hypotenuse is 18. So there's my equation that's going to tell me what x is. Sometimes you'll get questions like this on a test with no calculator. No calculator, no problem. Just solve for x by multiplying both sides by 18. And if you don't have a calculator, you would just leave your answer as 18 times the cosine of 60 degrees. Okay? If you do have a calculator, then make sure that you put your mode in degrees. If your angle is measured in degrees. If your angle is measured in radians, your mode will be in radians. So if you put your calculator's mode in degrees and then just type this in your calculator exactly the way you see it, then what you should end up with is 9. Okay? Now, another way that you can do this particular problem without a calculator, okay, is, and I'm going to erase that answer of 9 for a minute, other than if you don't have a calculator, this problem can be done without one because you know the cosine of 60 degrees. You can get that right off your unit circle. You know the cosine of 60 because you know your unit circle, right? You do know your unit circle, right? You better know it, okay? But the cosine of 60, according to your unit circle, and that would be the x-coordinate of the 60-degree angle, is 1/2. And when you multiply 18 times 1/2, you're going to get 9, just like your calculator will tell you. Okay, so number 5 here, we got a nice little word problem because everybody loves a word problem. Yes, they do. You like my song? You better like my song. You know you love my song. Okay, so we've got a 20-foot ladder that leans against the side of a house. Find the height from the top of the ladder to the ground if the angle of elevation is 80. We're going to talk about this angle of elevation thing, okay, in case you forgot it from Math 3. All right, but you've got the side of a house here. We're going to lean a ladder up against it, and of course, hopefully the house and the ladder are on the ground, okay? Wouldn't that be nice, okay? So this is my right angle. So this is my house over here. Whoa, that's some ugly writing. Let me try that again. This is my house, this is the ground, and this is my ladder right here. Okay? So, these are some things that I know. I know that my ladder is 20 feet. That's my R, because that's the hypotenuse of my triangle. So that is 20 feet. Okay? I need to find the height from the top of the ladder to the ground. So this is my height right here that I'm trying to find. That is Y. I don't know what that is. That is what I'm looking for. That's my big question mark. And the angle of elevation is 80. Now, angle of elevation means that it's the angle formed by a horizontal segment and a line of sight. So pretend you're standing down here and you're about to climb that ladder and you're going to be going up the ladder, right? Well, you're standing on the ground. Well, okay, maybe a little below the ground. Okay, sorry about that. You're standing in a sinkhole. There we go. I'm teasing. All right, but you're going to climb that ladder up here. Well, this is your angle of elevation because that's the angle that is formed with a horizontal segment and your line of sight looking up. Okay, so that is your 80-degree angle right there. So we've got to find Y. So again, well, let's identify some parts here. Let's see what we've got here. We know what this side is. We know our angle, but we don't know that side. So again, I'm going to have to write a trig function to do this because anytime you know 2 out of the 3 parts of a triangle, you can use Pythagorean theorem. But when you don't know 2 out of the 3 parts, you're going to have to use SOHCAHTOA, meaning you need to pick a trig function, sine, cosine, or tangent. Pick one of those to solve this problem. So that means that identifying my sides as R, Y, and X is not going to work for me this time. I need to identify each side as opposite, adjacent, and hypotenuse. Well, here's my hypotenuse. X is my adjacent side because that is the angle that is next to, that's the side that is next to this angle. And then opposite is across from this angle. So this is your opposite side. So what I see here is they want me to figure out the opposite side, and I know the hypotenuse. So you want to know the opposite, and you already know the hypotenuse. Well, which trig function uses those 2 sides? SOHCAHTOA, opposite and hypotenuse, right there. So that tells me that the sine of my angle is equal to the opposite leg over the hypotenuse. So fill in what you know. I know that my angle is 80 degrees. My opposite leg is y. My hypotenuse is 20. So I'm going to multiply each side by 20. So again, if you have no calculator, no problem. Leave this as 20 times the sine of 80 degrees. Okay? All right. If you do have a calculator, remember your mode needs to be in degrees. We cannot use our unit circle for this because 80 degrees is not on your unit circle. So you're going to just have to type this into your calculator the way you see it, and you get about 19.7 feet is how high up that house the ladder would be. Okay? All right. Number 6. Let's see what we've got going on here. From the top of a 172-foot high tank, the angle of depression to a house is 13.3 degrees. How far away is the house from the water tank? So we've got two objects going on here. And let's say that we've got our house over here. La-di-da-di, I'm building a house today. Do you like my house? Let's put a chimney on that house. Ooh, let's start a fire. There we go. Okay. Let me see. And then we've got some kind of water tank. Okay. Water tank is over here. Okay. So here's a nice little water tank over here. And it's a very creative water tank, isn't it? All right. So it says from the top of a 172-foot high tank. So I know that this is 172 feet right here. The angle of depression to a house is 13.3 degrees. That means you from the top, okay, that means you're going to start here at the top. Angle of depression means you're going to go down. So you're starting at the top and you're going to go down to this house right here. Well, a lot of students think that this is your angle of depression, but it's not, okay? Your angle of depression is actually formed by your line of sight looking down and some kind of horizontal segment, okay? All right, so this is actually your angle of depression. So this is your 13.3 degrees right here. Well, I know you're already thinking, well, wait a minute. Aren't I going to use a triangle that uses this segment, the tower, and the ground? Whoa, I meant to draw a line and didn't. Let me try that again. There we go. Well, I'm so glad you asked that question. Yes, we are going to use this triangle right here, okay? So this is your angle of depression right here, or your depression angle, sometimes is what I call it. Okay, well, your depression angle happens to be equal to your angle of elevation because they are alternate interior angles. Ooh, that is a vocabulary word from Math 2. That is a blast from the past. So this is your elevation angle. This is your depression angle because that would be like, you know, your dog is laying over here on the ground or something. That poor little doggy. There we go. There we go. There's your doggy. Okay. He's laying on the ground. He's looking at the top of that water tower because your cat got up there. Let me make that cat mean. Those are mean cat sounds, okay? So he's looking up there at the top where that cat is, okay? So the angle at which he's looking at the cat and the angle at which the cat's looking at him, it's the same. But for the cat, this is his angle of depression, and for the dog, this is his angle of elevation, and they are equivalent to each other, okay? So the problem asks, how far is the house away from the water tank? So how far is this point right here away from this point? So this is the segment we're looking for. I'm going to call that X, and this is going to be my Y, okay? So again, I've got an angle, I've got a side, and an unknown side. So again, I'm going to have to use Sakatoa here. La-di-da-di-da, Sakatoa, the Indian princess of Trig. Okay, so what are we doing here? Oh, we need to identify the parts as opposite, adjacent, and hypotenuse in reference to this angle. So this is my opposite side. This is my adjacent side. This is my hypotenuse. So I know my opposite side. I want to know my adjacent. Choose a trig function, sine, cosine, or tangent. Which one uses those two parts? Yes, you're absolutely right. It is tangent. So tangent of theta is equal to opposite over adjacent. Oh, we're going to have a plot twist on this one. Are you ready for it? Plug in what you know. Tangent of 13.3 equals the opposite leg over the adjacent leg. Oops, wait a minute. We know, wait, hold. There we go. We know why. That is, whoa, that is a highlighter. That is not my pen. There we go. 172 divided by x, okay? There is a little trick to solving these when x is on the bottom. Let me show you the long way first because you know how we teachers can be, okay? Multiply both sides by x. So what I have is x times the tangent of 13.3 is equal to 172. And then divide both sides by tangent of 13.3. So, if you didn't have a calculator, you would just leave it just like that. Tangent divided by, 172 divided by tangent of 13.3. If you do have a calculator, go ahead and put that in and figure out that you have that it's going to be 727.6 feet. That's the distance from the house that has no door or windows. We do now. Hey, want an attic? There you go. All right. All right. The trick to doing this is with the trig equations. If your equation has x on the bottom, just divide your numerator by your trig function. That's what we ended up doing. 172 was our numerator, and we divided it by the trig function. Then you don't have to go through all that, which I'm fine with. Okay? All right, next one. How far are we going? Anybody need a countdown? We're going to number 10, and we are on number 7. So an engineer builds a tower 75 foot high. What about a high in there? Okay. Find the angle of elevation to the top of the tower at the point on level ground 50 feet from the base. So we are building towers all day long, boys and girls. So here's our tower. Whoa. Building a tower. It's 75 feet high. 75 feet tall. Find the angle of depression to the top of the tower at a point on level ground. So how about some ground? Here's our ground, and it's level, okay? And we're going to go from this point to the top of that tower right there. So there's our right triangle, okay? So this is 75. Find the angle of elevation. Here's our angle of elevation right here. From a point on the ground, 50 feet from the base. So right here is my 50 feet. Okay? So, when you're looking at an angle and you don't know the other angle, you're going to have to use trig, Sakatoa. See, if we knew this angle and that one, well, we could just, we know the three angles of a triangle equal 180, right? We could do that, but we can't do that here. Okay? So, when you just know one angle and you need to find the other, let me back up. When you know one acute angle but you don't know the other one, I need to back up again. When you don't know either acute angle, there we go. You need to use the Indian princess of trig, Sakatoa here, okay? So identify your parts as opposite, adjacent, and hypotenuse, and then we're going to decide which trig function to use here. So in reference to theta, this is our opposite side. This one is our adjacent. which trig function uses adjacent and opposite. Dun, 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 dun. Did you get the hint? It's this one. Yes. So tangent theta is equal to the opposite divided by the adjacent. So tangent theta is equal to 75 divided by 50. When you are looking for an angle, when finding an angle, okay, then you must use the second key. So you're going to use, what you're going to type into your calculator is this. Theta is equal to second tangent. And when you press the buttons, second and then tangent. Okay? What pops up in your calculator is this, tangent to the -1. Don't try to put tangent raised to the -1, like an exponent. It's not going to work. You've got to do these buttons on your calculator, second and then tangent. And this pops up, tangent to the -1 with parentheses. And then you put this ratio, 75 divided by 50, into your parentheses. You don't even have to simplify that. The calculator will take care of that for you. And then out pops your angle of 56.3 degrees. Yes, sir. Number 8. Moseying right on along. We do love some right triangle trig. Find the, what about 5 trig functions? Because I've already given you one. The other 5 trig functions. How's that? Okay. Of theta, given that cosine theta is -4/5 in this range right here, pi to 2 pi. Oh, these are so fun to me. Okay. What we need to figure out is we need to figure out which quadrant theta is in. Okay. It's the first thing we're going to do. We're going to use good old ASTC to figure it out. Okay, here we go. Right here, we're between pi and 2 pi. So we're not here, we're not here. We've got to be in one of these 2 quadrants right here. How do we know which one? Easy. Okay, in this quadrant, cosine has to be positive, but in this problem, cosine is negative. So I'm not here. I must be in quadrant 3. I am going to sketch that triangle. Now, when you sketch a triangle on your coordinate plane, you will always draw your triangle such that, and remember, we're going to draw it right here in quadrant 3, but you're going to always draw it such that the hypotenuse of your triangle comes from the origin, and then the third side of your triangle will be perpendicular to the x-axis. You will never draw it perpendicular to the y. Never, ever, ever. It will always be perpendicular to the x. Okay? So this is the triangle in which I'm going to find theta. Okay? Now, remember that cosine is defined as x over r. So what that tells me here is that r is 5. And that x, which is my horizontal segment, is -4. So I am looking for y. Okay? So I am going to do r squared is equal to x squared plus y squared. So 5 squared is equal to -4 squared plus y squared. So 25 equals 16 plus y squared. 9 is equal to y squared. So y can be positive or -3. Well, here we go. You got to see which quadrant you're in. Isn't that segment right there beneath the x-axis? Isn't that in negative y territory? So that means y is -3. So now we can figure out sine, cosine, tangent, and come back for cosecant and secant and cotangent. And I know it when you like, I know you like for me to sing to you. Yes, you do. I know you do. Yes, you do. Okay, sine. Y over R, negative 3 over 5. Cosine, given to us, negative 4 over 5. Tangent, Y over X. Cosecant, we're going to flip sine. Secant, we're going to flip cosine. Cotangent, we're going to flip tangent. Check this out. What's always positive in the third quadrant? Yes, tangent and its inverse. Those are the only two that are positive. Everything else is negative. See, you did this right. You are so awesome. Number 9. The point 3, negative 5 is on the terminal side of theta. Find all 6 trig functions. All ordered pairs are given to you as x, y, right? What that tells me is that x is 3, y is negative 5. All I got to do is find r. How y'all doing? You loving this trig stuff? I love me some trig. Yes, I do. By the way, r is always positive. The radius of your circle, the hypotenuse of your triangle, it's always positive. Okay? Now that you have all of those, then you can plug and chug and get your 6 trig functions. So sine y over r, cosine x over r, tangent y over x. Da-da, da-da. Cosecant, we're going to flip sine. Secant, we're going to flip cosine. Cotangent, we're going to flip tangent. After I do my flips, that's when I come back and rationalize denominators. It's easier to flip before you rationalize. Hey, take it from me. I've done this for 28 years. There's a reason I act so stupid and crazy sometimes. Do you know what it's like to teach you guys for 28 years? It's awesome. It's one of the most awesome things I've ever done. I love you guys. Yes, I do. Oh my gosh, I heart you. Yes, I do. It makes my heart happy. Okay, are we on number 10 yet? Yes. Last one. I bet you're glad. Okay. Find tangent if secant is negative 9/4 and theta is in quadrant 2. Oh, was I nice enough to tell you the quadrant this time and not make you figure it out like we did a while ago over here? Remember how we had to figure out which quadrant we were in? That was so nice of me not to make you do that this time. Okay, so here we go. Again, you're going to want to draw your triangle onto your coordinate plane. And we are in quadrant 2. Now, when you draw your triangle, remember, the hypotenuse of your triangle is drawn from the origin. And then the third side of your triangle is perpendicular to the x, never to the y, always to the x. Okay? So here's my right triangle, here's my theta. Secant, I have to remember that secant is the same thing as r over x because it's the reciprocal of cosine. Alright, now, I cannot make r negative. R is never, ever, ever negative. R is always positive. So what I'm going to do is I am going to make that positive and make my 4 negative. So r is a positive 9. X is a negative 4, which makes sense to me because doesn't that side lie on the negative x-axis anyway? And then we have to find y. So a little r squared is equal to x squared plus y squared. That's going to be 81 equals 16 plus y squared. Subtract your 16, you're going to get 65 equals y squared, and y is square root of 65. Did you keep up with that? If you didn't, pause me, rewind me, okay? And let me see, tangent. Tangent is y over x. Oh, by the way, remember here y can be positive or negative. But I know it's going to be positive because when you're in the first two quadrants, y is positive territory, okay, not negative. So your tangent is going to be y, which is square root of 65, over x, which is negative 4. Now, does it make sense for tangent to be negative in quadrant 2? Oh, yes, sir, and yes, ma'am, it does, because it tells you, ASTC tells you tangent is positive in these two quadrants. Therefore, tangent would have to be negative in these two. And there's your quadrant 2 right there. Okay? So that is the end of right triangle trig, and I know you thoroughly enjoyed it. So if you did, be sure to tell my administrators just how wonderful I really am. You know you want to. Okay, well, you have a hunky-dory day.